The quadratic function y is equal to ax squared and linear function y is equal to mx plus n intersects at points A and B. Point P on the line AB and its x-coordinate is P, where P should always be greater than 0. We need to solve two things in this question, and the first thing that I'm going to show in this video, we're going to be solve for the value of A, M, and N and express PQ into point P. There are two things that we need to remember when it comes to solving this kind of questions. First of all, we need to think about how to solve the unknown variables, which means A, M, and N, using some stuff. And first of all, when it comes to solving the unknown variables, we need to use the simultaneous equations. And there are three kinds of ways that we can approach our simultaneous equations, and I'm going to talk about it in the next video. And first of all, let's think about why we use simultaneous equations. First reason is because we're trying to find the unknown variable through simultaneous equations, but the most important point or the way why we're using is because we're trying to find the intersections between two graphs or two functions. That's why we use this equation. In the next video, I'm going to talk about the three ways of simultaneous equations. But when it comes to solving this or applying this equation, we need to have some information. But the information will going to be some specific points. So the only points that are given in this case will going to be B. Even though they gave us the value of the A value, which will going to be the x-coordinate of A value -3, we can input that back to our original function and find the output of a function, which we usually notated as y. But then it includes so many variables. So first of all, let's think about the point B. So the point B, which is the intersection point between two graphs, which means it satisfies either the linear or the quadratic functions. And its point or the coordinate will going to be 6, 12. And if you think about what this each variables or your point does, first of all, our 6 is always should be the input of our function, which we usually notated as the x point, x coordinate. 12 should always be the output of our function, which we usually notated as the y or f of x. This is what the point B will look like. And in this case, first of all, let's think about how to solve the point or the A. As we can see, there is a quadratic function y is equal to ax squared, and our A is the leading coefficient of our quadratic function. And let's think about what it does. So first of all, it defines the types of our graph and our vertex. So if you think about what that means, so when the first case of our quadratic function will gonna be when our A value, our leading coefficient, is greater than 0. Which means when it is positive value, the graph of our quadratic function's graph will open upward. And if you think about what it means by opening upward, is, for example, I'm going to draw one example of our upward graph, which will look something like this, that keeps going toward upward and never intersects at some point. But then you want to contain one specific point in this case, which is one of the most important things in our quadratic function, which we call it as the minimum point, or the lowest point on our graph. And this will occur when our A value is positive value. So this is the first case of our quadratic function. Let's think about the second case. The second case is that when A value, our leading coefficient, is negative, less than 0. Then when our graph or a quadratic function will open, unlike the first one, going downward. When the quadratic function opens or it goes downward, for example, it will look something like this, that keeps going toward downward. And we're going to contain one important thing, another important thing in our quadratic function, which we call it as the maximum or the highest point on our quadratic function. And this will occur when the A value is negative value. And from here, we can think about the definition of our vertex. So the vertex, the actual definition of our vertex is, it is the same thing with adding the number of possibilities between the minimum and the maximum point. And that gonna give us the vertex. When it comes to applying our simultaneous equations to our functions, we need to have some information which will going to be the points in this case. And the only point that is given will going to be b, which will going to be the intersection between the quadratic and the linear function. So in order to solve for our a value, all we have to do is we need to input our b, which will going to be 6, 12 back to our function in order to solve for our a value. So if you apply our point, it will going to be our input x, so 12 will going to be our output, which will going to be y value, and it will going to give us 8 times input square, and we could get that 12 is equal to 36a. So if you simplify our expressions, we're going to get our a value, which we call it as the solution or the output or the answer, which will going to be 1/3. So our leading coefficient of our quadratic function was a, which means we could get our full function. And our full quadratic function will going to be y is equal to 1/3 x squared. So we could solve for our a value, which will going to be 1/3. And now all we have to solve is m and n. But m and n are all from our linear function. So before you think about this m and n, let's think about what this linear function will look like. So the basic structure of our linear function will going to be y is equal to mx plus n. And if you think about what this each variable does, so the first case will going to be y and x. And y and x should always be whenever the function is output and input. And if the reason is because the function always requires some specific output and inputs. And secondly, what will going to be the m and n. M will going to be the slope of our function, which means how steep the function is, and n will going to be the y-intercept. And if you think about what this y-intercept does, the y-intercept will going to be when it converts this into some specific coordinates, it will going to be 0, y, which means when our x value, our input is equal to 0, our y value exists. But the y value, we just notate it as y because it is a variable and it changes or it varies depends on times. For a formula of a linear function, quadratic function, if you convert this into a some specific graph, it gave us the parabola. But the linear function is different. It will going to give us a specific line that satisfies our functions. And this is what the linear function will look like. And if you think about the basic structure of our function, the function is a stuff, as I have said, it always requires a specific input. And with that input, the function will occur. And then it's going to generate some specific output as we inputted our specific input. And if you think about the basic definition of a function, it should always be the expressions between the y and the x. But our linear function means our x variable has the first degree power term. So this is what our linear function will look like. Before you think about solving for the m and n, let's think about the point A. And point A is also an intersection between the quadratic and the linear function, which means when we input our values from our a value, it will going to give us same output as the linear and the quadratic function. So we know that every single points are formed by the x, y in our coordinate plane. But then in this case, our x value was -3 as they gave us. So our input of our a value was -3. But we couldn't solve for our output because they gave us so many variables in it. But then as we solved our quadratic function, which was y is equal to 1/3x squared, we could input our -3 easily to our x value to solve our y value. And if we calculate it, we're going to get the y value in this case. We're going to be +3. So for our conclusion, our a value will going to be -3, 3. So it is time for us to apply our simultaneous equation since we have our 2 points. And we usually use our simultaneous equations when there are 2 variables. And in this case, the 2 variables were going to be x and y. So first of all, let's input our first point, b, to our linear function. And if you remember what our linear function was, it was y is equal to mx plus n. So if we input our b point, which was 6, 12, it will going to give us the output is 12. That is equal to our input 6 and then times n plus n. This will occur when we input our b value. And the only reason why we could use our simultaneous equation is because a and b are both intersections of our linear and quadratic function. So we solve for our stuff. Let's write it down again more in a neat way. 12 is equal to 6m plus n. Let's think about when you input our second point, a. So let's remind ourselves what the linear function was. Y is equal to mx plus n. And our point a, so our point a was -3, 3. And if you input a specific output of our function, it will going to give us 3 is equal to -3 x plus n. And from here, we can use simultaneous equation between these 2 expressions to solve our m and n. So if you use it, first of all, let's write it down again together. Y is equal to 6m plus n. And then 3 is equal to -3x plus n. And there are 3 ways of solving for a simultaneous equation, but in this case, I'm going to do the substitution rule, which means we can subtract this to remove one of our variable. And if we subtracted our one variable, which will going to be our n value, we're going to be removed. So we're going to get 9 is equal to 3m. 9 is equal to 3m. But when it comes to solving for our simultaneous equation, one thing we need to be careful is we need to always do it by the order, which means a was our first order. So we need to put our a first. 3 is equal to -3x, or m in this case, plus n. And then we have 12 is equal to 6m plus n. All we have to do in this case is subtract them to remove our n value. And we're going to get, eventually, -9 is equal to, -9m. So if you divide -9 to the both sides, we're going to get m is equal to +1. So our m, which we're going to be our slope in our quadratic function, was n. So we could write it as the answer, m was the slope. And our answer was 1. And since we solved our n value, we can easily solve for our n value all you have to do is we need to input this back to our original function, whatever that be. Let's input 3 is equal to negative 3n plus n. So if you input 1 to our n value, we're going to get 3 is equal to negative 3 plus n. And from here, if we add 3 to the both sides, we could easily get n is equal to positive 6. So we figured out whole answer, which was n, our y-intercept, which was positive 6. And we could use it through our simultaneous equation. Picture it is a little bit weird, but then the real picture was P and a Q are straight, which means they share a same x coordinate, but a different y coordinate. So let's think about the point P first. The point P, we're going to be P, comma, y as they gave us through the information. So all you have to do is we need to input this back to our linear function because it is a point on our linear function. And we can make the full linear function as we have solved every single variables. So at first, our variables, our linear function with the variables was y is equal to mx plus n. But then m was 1, n was 6. So we could easily change it as y is equal to x plus 6. This will going to be our full linear function. So if we input our p into as our input of our function, and our y as the output of our linear function, it will going to be y is equal to m is 1, so p plus 6. So our full coordinate of our p, we're going to be x, which we're going to be p, comma, p plus 6. This will going to be our point P's coordinate. And solve Q. Now, when it comes to solving for our lengths, it is the difference. So it is a difference between the coordinates, which means we also need to solve for our Q coordinates, but the Q coordinate is on our quadratic function, which means we can apply this to our linear function. So our point Q, we're going to be p comma y, and we're trying to solve for our y value since we knew that there is no difference between the x coordinate. If we do it, we're going to get, first of all, let's repeat our quadratic function. Y is equal to 1/3 x squared. And if we input our p value into our x value, we're going to get y is equal to 1/3 p squared. 1/3 p squared will going to be our y value. So for our full coordinate, it will going to be p comma 1/3 p squared. So the lengths between the point P and the point Q will going to be difference between the coordinate, which means there is no difference between P because they're all x values. But there is a difference between P plus 6 and 1/3 p squared. So all you have to do is we need to subtract or add together. So the difference between both of them is p plus 6, which will going to be our y coordinate of our linear function, minus our 1/3 p squared, which will going to be our y value of the quadratic function. So this was going to be our total answer since we knew that we can't solve exact value. So our answer for our question will going to be -1/3 p squared plus p plus 6. And in the next video, I'm going to talk about the 3 ways of solving the simultaneous equation, as well as the second part or the second question of our same question.